Now, understanding that our worldview significantly informs how we think, let's turn our attention to some of the key concepts associated with the thinking that is characteristic of systems thinking. We started off by talking briefly about systems, and there are a number of different properties of systems, as this systems thinking aperture shows. So, for example, self-organization, structure, emergence, unpredictability, flux, contingency, interconnectedness we talked briefly about. We talked about holism, we haven't talked about equilibrium, but systems tend towards equilibrium. There are states and there are attractors. Systems are adaptive, they exhibit variety. There's information flows, there's a reciprocal influence. There are a range of attributes of systems. Beyond the attributes of systems, we need to think about the attributes of our thinking, contexted by those. And there are a number of issues there that emerge. We don't have time to go into all of those at the moment, but what we will do is we will explore some of the critical ones that relate to our journey through systems thinking. The first one is perception, and I'm sure that you've all heard about the iceberg model. Freud originally used it to describe the nature of the unconscious insofar as there was a very, very small tip of what was seen, and then below what was seen, there was the 8/9 of what was unseen. The iceberg model similarly tells us that at that what is seen area, that's the observable phenomena, that's the events that we can see. And then in the underneath area where there are unseen things, the first level of that are effectively patterns of behavior. They emerge as trends over history. Below that are the underlying structures, that the influences and the relationships that give rise to those trends over time throughout history. And then underneath that, there are the mental models and the assumptions and the beliefs and values. One of the very interesting things I think about the iceberg model is that there's a strange little analogical value that we can tie to complexity. Because of the iceberg breaks off from the ice shelf, it floats out into water, and because of the nature of the ice, it's got a higher concentration of iron, shown by all the little Fe symbols there. So as a result of the melt water around the iceberg, there is a higher concentration of iron. The higher concentration of iron attracts phytoplankton. Now, phytoplankton become the food for krill. And as a result, what happens is around an iceberg, which is broken off as a result of global warming from the ice shelf, there is a significant amount of carbon sequestration. The carbon sequestration that occurs around icebergs, I think, is about 15% of global carbon sequestration in total. So the strange, weird paradox about an iceberg is that an iceberg is going to break off from the ice shelf as a result of global warming, but yet it is going to contribute to carbon sequestration, which is an offset to the effects of global warming. A nice little analogical parallel to the notion of complexity. Moving on from the iceberg is the notion of perception. Now, William Blake, the artist and the writer, basically said, I see everything I paint in this world, but everybody does not see alike. The tree which moves some to tears of joy is in the eyes of another only a green thing which stands in the way. As a man sees, so he is. This is a picture from Peter Dombrovskis, taken in 1984 near Mount Anne in southwest Tasmania. So clearly, not everybody sees the same thing, but yet the way that we see has a determining effect on what we think. Now, George Lewes, in contrast to the idea of a resultant, developed the idea of an emergent. And he's quoted as saying in his book, Problems of Life and Mind, although each effect is the resultant of its components, the product of its factors, we cannot always trace the steps of the process, so as to see in the product the mode of operation of each factor. In this later case, I propose to call the effect emergence. It arises out of the combined agencies, but in a form which does not display the agents in action. Clearly, what he's trying to say there is that emergence is unlike its components insofar as they're incommensurable. In other words, an emergent phenomenon cannot be reduced to the sum or to the differences of its preceding factors. Now, a very good example of emergence is water. Hydrogen, oxygen are gases, and yet water is a liquid. The wetness of water is a characteristic that could not possibly be deduced from the nature of its components. It is a new characteristic. Now, we know that in certain environments, on certain surfaces, hydrogen and oxygen combine to produce wet water. In different environments and on different surfaces, it might be steam, it might be ice, it might be supercooled liquid, but yet the fundamental expression of the resultant phenomena arising from hydrogen and oxygen is in actual fact an emergent phenomena, and we don't know how it is undertaken. Similarly, we could look at anthills. They're not planned, they're not controlled. The interaction amongst the millions of ants produces patterns and properties that emerge to inform the whole system. So an anthill or termite hill is a maze of interconnected passages, large caverns, ventilation tunnels, and it emerges as a result of activity. There are many examples of emergence, and emergence is one of the critical aspects of complex systems. For example, to illustrate very, very simply, we've got a number of different parts here. We've got a circle, we've got two dots, and we've got a bent line. We can't appreciate any emergent phenomena out of those parts. However, if we arrange them one way, we get something which we can relate to. We get another way, and we can relate to that. So consequently, mood is an emergent property in this particular exercise that results from the arrangements of the parts. Similarly, perspective, leading on from perception. This diagram here is Hayakawa's abstraction ladle, where he's actually talking about Bessie the cow. So the cow is in actual fact an arrangements of atoms, and the farmer's daughter might refer to the cow as Bessie. And in this particular case, it might be that Bessie could also be referred to by the farmer as livestock. The accountant might refer to the cow as a farm asset or perhaps as an asset, and ultimately the economist might look at the cow or the combined asset as a measure of wealth. So perspective determines how you look at something. It's based on your involvement. It's influenced by your worldview. It's influenced by your experience in your environment. However, we need to recognize that it's quite unique. It is necessarily limited. It is partial and incomplete. The object of our experience then is not the thing in itself, but the interaction between our nervous systems with all their imperfections and something outside them. So ultimately, perspective plays a determining role in the way we think. For example, we've got visual examples of perspective. We have other visual examples where two people can look at the same thing from a different perspective and they see a fundamentally different thing. Moving along, Donella Meadows states that there are no boundaries. There are no separate systems. The world is a continuum. Where we draw the boundary around a system depends on the purpose of the discussion, the question we want to ask. Boundaries are therefore of our own making, and they should be reconsidered for each new discussion or problem or purpose. So in every respect, boundaries are artifacts. They're cognitive artifacts of our inquiry, and we will talk about boundaries when we talk about critical systems heuristics. Related to boundaries and perspectives is where we draw in. So for example, where we draw the boundary, based on our limited perspective, is the line around which, or it's how much detail we want to look in. So the diagram here hopefully tries to illustrate that as we zoom in and as we zoom out, we're effectively drawing a boundary differently, and we're actually creating a different system. We're creating a different thing. A couple of other very important concepts that we need to remember as we take our journey through systems thinking are the complementary roles of analysis and synthesis. Analysis, from the Greek word, basically means to loosen up or to pull apart. Synthesis, alternatively, comes from the root word, which means to put together or to put back into place. So analysis and synthesis are two complementary but nonetheless opposite attitudes towards thinking. Analysis helps us understand the parts. Synthesis helps us try to understand the containing whole. Analysis aggregates our understanding of the parts into the understanding of the whole, whereas synthesis enables us to identify the role or the function in the system of which the part is a component. Analysis reveals the structure of how something works. It provides us with knowledge. Synthesis reveals an understanding of why it works the way it does. It's an explanative thing. So in order to understand the nature of a system, we need to involve both, or we need to employ, I should say, both analysis and synthesis. One of the important issues that comes to mind when we're thinking about looking at systems is our role as an observer. And Malinowski, when he was in New Guinea, has made a very, very interesting comment about observation. As to the actual method of observing and recording in fieldwork, these imponderabilia of actual life and typical behaviour, there is no doubt that the personal equation of the observer comes in here more prominently. What he's basically saying there is we need to be absolutely aware of our own involvement as an observer. And this picture here, which shows Malinowski sitting in his tent at the typewriter, typing up his notes of the local people, whilst the local people are watching him typing up his notes. And the interesting thing here is that there's also obviously a photographer taking a photo or observing the people who are observing the person who's been observing them. And the photographer is observing both of them. So there's a very, very interesting co-involvement, co-determining influence of the observer and the observed in the act of observation. So systems thinking, in summary, is a non-reductionist way of looking at the whole and not just the parts. It's non-linear insofar as causal multiplicity and mutuality and primarily emergence are important characteristics of the interaction and the dynamism created by the interconnectedness of the parts. System thinking tells us that our thinking has to be situated, it has to be framed, and is therefore contingent. So the notion of perspective, the notion of perception, and the overarching background of worldview tells us this as well. Systems thinking is about analysis as well as synthesis, loosening up and putting back together again. In actual fact, I like to think that systems thinking is a largely appreciative process. It's appreciating connections, it's appreciating patterns, interconnectedness, it's appreciating feedback and reciprocal influence.